The height of the circular cone is 30 centimeter. So it is constant. What is the volume of a cone? V is equal to 1 by 3 pi r square h. Let's substitute here. So it is 1 by 3 pi r square into 30. You can cancel. So we get V is equal to 10 pi r square. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in our previous session, we were taking the problems and solving it on the rate measure. So we will continue solving the problems on rate measure in today's session. So the very first question here is, sand is being dropped at the rate of 10 meter cube per second into a conical pile. If the height of the pile twice the radius of the base, at what rate is the height of the pile is increasing when the sand in the pile is 8 meter high? So what is the condition given? A sand is being dropped from a conical pile, it's cone shape pile, and if it is dropping, it forms a cone shape. So it is dropping at the rate of 10 meter cube per second. So the volume of the sand is increasing at the rate of 10 meter cube per second. So the rate of change of volume with respect to time is given as 10 meter cube per second. Next, they have given the height of the cone of the pile is twice the radius of the base. That is, they have given h is equal to 2r. Next, we need to calculate the rate of change of height that is increasing when the height of the sand is 8 meter high. So that is, we need to calculate dh by dt when h is equal to 8 meter. So this is what we have to calculate. So let's see the formula for the volume of a cone. What is the volume of a cone? V is equal to 1 by 3 pi r square h. So here we have h is equal to 2r. So we need to calculate dh by dt. So when they have given h is equal to 2r, I can write r is equal to h by 2. So replace here r is equal to h by 2. So then the volume becomes 1 by 3 pi h square divided by 4 into h. Now here the volume is equal to, here we have 3 4s are 12. So 1 by 12 pi h cube. Let us derive it with respect to t. So dv by dt is equal to 1 by 12 pi 3 h square into dh by dt. Now here the height of the pile is given, that is 8 meter. dv by dt is given as 10. So it is 10 is equal to 1 by 12 pi into 3 into 8 square into dh by dt. So on solving this, we get dh by dt is equal to, here we can cancel 3 1s are 3 4s are. So here we get 64 because 8 square. So when you cancel it, you will get this as 40 divided by 64 pi. And again when you cancel this, dh by dt is equal to, so this is 8 5s are 40, 8 8s are 64 pi, and this is meter per second. So what is dh by dt? dh by dt is the rate at which the height of the pile is changing. Next question. A ladder of 15 feet long leans against a smooth vertical wall. If the top slides downwards at the rate of 2 feet per second, find how fast the lower end is moving when the lower end is 12 feet away from the wall. Now, we have a ladder which is leaned against a wall which is 15 feet tall. Now, if I decrease the height here, then it slides this side. So now it is moving in this direction. So they have given if the top slides downwards, so it slides downwards at the rate of 2 feet per second. If I take this as y and if I take this as x, they have given dy by dt is decreasing at the rate of 2 feet per second. Now, when it is decreasing, this ladder is increasing the distance from the wall. That is, we have to calculate dx by dt when the lower end is 12 feet from the wall. So, when the x is equal to 12 feet from the wall. Now, here clearly we get this as a right angle triangle. So, using the Pythagoras theorem here, I can write x square plus y square is equal to 15 square. So, this is now x can be taken as 12. So, it is 12 square plus y square is equal to 15 square. Y square is equal to 225 minus 144, which is equal to 81. If y square is equal to 81, we can write y is equal to 9 feet. Now, let us take this as equation and we derive it with respect to x. So, from 1, if you differentiate it, we get this as 2x into dx by dt plus 2y into dy by dt is equal to constant is 0. 15 square is a constant and its derivation is 0. So, we can take 2 outside. Since it is not equal to 0, I can write x into dx by dt plus y into dy by dt is equal to 0. Or we can say we can divide 2 on both sides. Now, we know the value of x, which is 12. So, I don't know what is dx by dt. Plus y, I got it as 9. Dy by dt, here it is 2 feet they have given, that is equal to 0. Now here, I'll get dx by dt is equal to shift this that side, 9 2s are 18, which becomes minus 18 divided by 12, or it is 3 by 2 feet per second. So you have a negative sign here. So, it is minus 3 by 2 feet per second. Minus indicates the decreasing or increasing value. So, here since y is decreasing, we can take this as minus 2 also. Then we will get the answer as positive. So, therefore, it is changing at the rate of 3 by 2 feet per second or 1.5 feet per second. Next one. An edge of a variable cube is increasing at the rate of 10 centimeter per second. How fast in the volume and also its surface area increasing when the edge is 5 centimeter long. So, edge of the cube, we know that cube has equal sides. So, it is increasing at the rate of 10 centimeter per second. Suppose I take A as the side of the cube, then change in the side is written in the form of dA by dt at 10 centimeter per second. Here we need to calculate the volume of a cube, the rate of change of volume and also the rate of change of its surface area whenever the side is 5 centimeter long. Let's see the volume. So, the volume of a cube is A cube. So, therefore, when you differentiate it, it is dV by dt is equal to 3a square into dA by dt. So, substitute here 3 into 5 square into 10. So, therefore, the change in volume can be written as 750 centimeter cube per second. Now, let's calculate the area of a square. So, area of a cube is given by 6a square. So, when you derive it, it is dA by dt, which is equal to 6 into 2a into dA by dt. So, again it is 6 into 2 into a is 5, dA by dt is 10. So multiplying these values, we will get the answer as 600. Since it is area, it is centimeter square per second. So this is the rate of change of area whenever the side of the cube is 5 centimeter. The next question, the height of a circular cone is 30 centimeter and it is constant. If the radius of the base is increasing at the rate of 0.25 centimeter per second, find the rate of increase of volume of the cone when the radius of the base is 10 centimeter. So what is given? The height of the circular cone is 30 centimeter. So it is constant. So h is equal to 30 centimeter. Next, the radius of the base is increasing at the rate of 0.25 centimeter. So therefore what I can write this as dr by dt is equal to 0.25 centimeter per second. Next, they have given to calculate the rate of change of volume, that is dy by dt of a cone whenever the radius is equal to 10 centimeter. Now let's see the formula to calculate the volume of a cone. So that is V is equal to 1 by 3 pi r square h. They have given h is equal to 30 centimeter. Let's substitute here. So it is 1 by 3 pi r square into 30. You can cancel. So we get V is equal to 10 pi r square. Now let us differentiate it. So we get dV by dt is equal to 10 pi into 2r into dr by dt. Now we need to calculate the change in volume, that is 10 pi 2 into r is given as 10, dr by dt is given as 0.25. So when you multiply this, dV by dt is equal to, so 20 into 0.25, that is 1 by 4th of 20 is 5, 5 tens are 50, so you will get it as 50 pi centimeter cube per second. So this is the rate of change of volume when the radius is 10 centimeter. Next question. A drop of ink spreads over a blotting paper so that the circumference of the blot is 4 pi centimeter and it changes 3 centimeter per second. Find the rate of increase of its radius and also find the rate of increase of its area. So given the circumference is 4 pi centimeter and circumference changes at the rate of 3 centimeter per second. Next, we need to calculate the change in radius as well as the change in the area. Now let's see, we have C is equal to 4 pi. So since a drop of ink, a drop is, we consider it as a circular form. So therefore the circumference of a circle is given by 2 pi r. Now this is given as 4 pi is equal to 2 pi r. Pi cancels, 2 ones are 2 twos are, therefore we get r is equal to 2 centimeter. Now we need to calculate the change in radius as well as change in its area. So let's take this equation only. Let's differentiate this. We get it as dc by dt is equal to 2 pi dr by dt. dc by dt they have given us 3. So it is 3 is equal to 2 pi dr by dt. So therefore I can write change of radius with respect to time as 3 divided by 2 pi centimeter per second. Now this is the change in radius of the drop of a ink. Let's calculate its change in area. So area is equal to pi r square. Change in area with respect to time is dA by dt pi 2r dr by dt. Now dA by dt is equal to pi into 2, r is 2, dr by dt is 3 by 2 pi. Let's cancel 2 pi cancels. So therefore dA by dt is 6 centimeter square per second. So this is the change in area of a ink drop. Next question. The surface area of a spherical soap bubble increasing at the rate of 0.6 centimeter per second. Find the rate at which its volume is increasing when its radius is 3 centimeter. So they have given the change in area of a spherical soap. So what is the area to find out a spherical soap? It is A is equal to 4 pi r square. For a spherical shape, area is 4 pi r square. So change in area is given. So let me calculate. dA by dt is equal to 0.6 centimeter square per second. So they have us to find dV by dt whenever r is equal to 3 centimeter. Let's take here dA by dt. We know area is equal to 4 pi r square. So dA by dt is equal to 4 pi into 2r into dr by dt. Now radius is given as 3 centimeter. Change in area is given as 0.6 centimeter. 4 pi into 2 into 3 into dr by dt. So we can cancel this as 2 3s are 6 one time and this is 0.1 times, or we can write this as 1 by 10. So this I'll write it as 1 by 10 is equal to 4 pi into dr by dt. So therefore dr by dt can be written as 1 divided by 40 pi centimeter per second. So this is the change in radius. Let us calculate the change in volume now. Volume of a sphere is 4 by 3 pi r cube. Now change in volume is dV by dt is equal to 4 by 3 pi into 3r square into dr by dt. So 4 by 3 into pi into 3 into 3 square into this is 1 divided by 40 pi. So we can cancel 3, 3. Here 4 ones are, 4 tens are, pi and pi. So we get it as 9 by 10, or dV by dt can be written as 0.9 centimeter cube per second. So this is the change in volume. Next question. A street lamp is hung 12 feet above a straight horizontal floor on which a man of 5 feet is walking. How fast his shadow lengthening when he is walking away from the lamppost at the rate of 175 feet per minute. Now, here is a street lamp which is 12 feet and a man is moving from the lamppost. He is 5 feet. This is the floor. From here the man is moving at the speed of 175 feet per minute. So this is, let me take this as x. So this distance is x. Change in x is 175 feet per minute. If a man comes here, let his shadow be this. Let this be the shadow of a man. I'll take this as y. So now this is A, B, C, D, E. Let this complete length be Z. So you can see a street lamp of 12 feet, a man of 5 feet. A man is moving from here. Let the distance, change in distance be 175. Let the distance be dx. They have given the change in distance, that is dx by dt is equal to 175 feet per minute. So let y be the shadow. We need to calculate the how fast shadow is lengthening, the change in shadow. We need to calculate dy by dt. Now, from the figure, clearly, both are similar triangles because they are right angle triangle. So what I can write here is AB by CD is equal to BE by DE. So this implies AB is 12, CD is 5, BE is means complete length, that is Z, which is nothing but X plus Y, and here it is Y. So cross multiply, we get it as 12Y is equal to 5X plus 5Y. Or we can write this as 7Y is equal to 5X, because 12 minus 5Y becomes 7Y, which is equal to 5X. Now we know the change in walking. Now we need to calculate the change in shadow. So therefore, if you differentiate this, this is 7 into dy by dt is equal to 5 into dx by dt. So which is dy by dt 7, 5 into 175. This implies dy by dt is equal to 5 into 175 divided by 7. 7 1s are 7 2s are 14, 7 5s are 35. Now therefore dy by dt is equal to 125 feet per second. So what is this? The shadow is lengthening. So this therefore the shadow is lengthening at the rate of, we can conclude, 125 feet per second. So this is how, using the differential calculus, that is by means of differentiation, we can find the rate measure of one quantity with respect to another. We'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.